You might not know anything about entropy, or you might have heard that it's a measure of disorderliness or randomness in something. This description doesn't capture the significance of entropy. Entropy is one of the primary movers of the universe. It is a major reason why any actions happen at all. Why do certain chemical reactions take place when you mix substances together, and why do others not? Why is it that two objects in contact with each other, one hot and one cold, result in a warm intermediate state? Entropy is a key reason. To start, we're going to look way down to the atomic level. Atoms are able to move and rearrange themselves quite readily. Consider a simple example where there are just two atoms moving around in a confined space. Let's track their positions very simply by delineating the left side of the space from the right side of the space. There can be two atoms on the left side or two atoms on the right side within the space. These are actually fairly ordered arrangements since both the atoms are together in one spot. However, the atoms can also be split across the divider where one is on one side and the other is on the other, and vice versa. In this case, they're a little more disordered and spread out. You'll see the picture changes very quickly when we add more atoms. For example, like 2,000 atoms. How many ways are there to organize the atoms so they are completely on the left? Still just one way. But how many ways are there to arrange the atoms so that only one atom is now on the right side of the space? There are now already 2,000 ways, so going from completely well organized as a microstate to slightly disorganized is already a major jump. It turns out that the microstates with the largest number of possibilities for arrangement are closer to the middle, where the atoms are more evenly distributed between the left and right sides, say about 1,000 on each side. The possibilities for these arrangements of atoms completely dominate in number and likelihood. There are 2 times 10 to the exponent 600 combinations. Just to give you some perspective here, the total number of particles in the entire visible universe is about 10 to the power of 80. A measurement of these different possible microstates is captured in the quantity that we call entropy. So when there are more possibilities of atomic arrangements, we say there is more entropy. And entropy tends to increase in processes and the whole universe.